As we start looking at cones, we're going to steal some of the same information we got from pyramids and apply it to cones. So even the vocabulary, a 3D figure, the base is one circle, and there's only one base. You'll remember the lateral surface rises up from the base and hits that point at the top called the vertex or the apex. And the distance from that vertex or that apex point, going straight down and hitting right at the center of our base, that's known as the cone's height or the altitude. But when we come straight down along the surface, along the lateral side, then we're talking about the slant height, just like we saw in our pyramid. And we're still going to use L to represent slant height. So L for slant height, and we'll use H for our regular height or our altitude. Cones and pyramids are both alike and different. Let's do a little compare and contrast. In a pyramid, remember, it's only got the one regular polygon base, at least the ones we're going to study. And the cones, they've got one circular base. Back over to pyramids, many of the lateral faces, you got all those triangles, you could have as many as you want, just depends on how many sides you have on the base. And then in our circle, we're only going to ever have one lateral surface. It'll be that one continuous curved surface. But what do they have in common? Well, they both only have one base, and that means they use the same formulas, and that's really awesome. They also have this little internal right triangle built of the slant height, the altitude, and down at the bottom, depending on what it is, the apothem, if it's on a regular pyramid, or the radius if we're talking about a cone. So that distance right there, I guess, is different for those. So formula-wise, we're looking at the same thing we saw with pyramids. You'll remember the pyramid is half of the perimeter multiplied by the slant height. And remember the slant height, let's get that in our pictures right here along this side. Well, when it comes to a cone, the perimeter isn't called the perimeter anymore. It's still the distance around the base, but that's the circumference. And remember, circumference is 2 pi r. So we're going to need the radius. Let's change perimeter to circumference, and let's just make note that it's half of 2 pi r times that slant height. Now let's take this one more step, because half of 2, guys, that's just 1. Those are ninjas. So our final formula, the way we're going to use it in its simplest form, is pi times the radius times the slant height. That's the one we're going to use. It's really straightforward. Now if we want to get the whole surface, we would take the lateral plus that one base that we have. And so bringing down the lateral area formula from above, that's pi r times slant height plus a base area. Just one base, one circle, pi r squared. And that's the formula we'll use for surface area. So let's check it out in an example. We're going to find both lateral and surface area of this cone. So let's jot down our formula for lateral area, pi r times slant height. We know the radius is 5, so that we can plug right in. But we do not know the slant height. We don't know this distance. I do notice it's a 30-degree angle, and with the 90, this must be a 30, 60, 90. So if this is 5, I can get that slant height just from my special right triangles of 10. It's nice to know those. So this is done. We just need to put it all together and call it 50 pi, and this would be in square feet. And, oh, I thought we were done. Nope, they want an approximation to the nearest tenth. So last step, grab a calculator. And we got that to the nearest tenth, 157.1 square feet. Okay, before we leave this, we're going to get the total surface area. So for the whole surface area, let me just get pi rl plus one base, that's pi r squared. Again, I just did that. I'm not doing it again. Let's bring down that 50 pi from up above, and then we just tack on one circle with a radius of 5 still. So square that. So that's going to be 25 pi. 25 pi, add that to the 50 pi, and we've got 75 pi, or about 235.6 square feet. That's how we do it, folks. Okay, last example. Again, we're finding lateral and surface area, so I'm going to jot down my formulas. Pi RL, and for surface area, that same pi RL, we'll just carry it down plus a base, pi r squared. All right, let's see what we can do here. So, do we know the radius and the slant height? Well, take a look. I know the radius right here is 9. Easy peasy. And slant height, no slant height given. Gotta find it. This time it looks like a Pythagorean theorem. Let's take 9 squared plus 12 squared. Set it equal to that slant height squared. Now I'm noticing a triple here if you don't see it. Let's take that 9, 12 something. Notice that 9 is 3 times 3 and 12 is 3 times 4. So this is going to be 3, 4, 3 times 5. This is 15. Alrighty, so slant height is 15. And multiplying this is going to bring me to 135 pi, or about 424.1 to the nearest tenth. And this is units square centimeters. They wanted both answers, so I'm going to circle them both. Okay, let's finish it off. Bring down the 135 pi. That's all of this. 135 pi from up above. And then let's add in a pi r squared. Radius is still 9 for this problem. So 135 pi plus 81 pi makes us a grand total of 216 pi. And that is about 678.6, also square centimeters. So I think you can see anytime there's a circle involved, straightforward formulas, and they make them nice. These are my fave.